Okay, hello everybody. We're going to do part 3 of experiment number 2. And the first thing we're going to do is look at the reaction of magnesium and water. And here is some magnesium turnings. Can you see it? It's a metal. It's got a little bit of oxide coating on it. It has a metallic appearance. It looks like silver when it's polished. And what I have in here is 10 milliliters of water. And I'm going to add 1 gram of the magnesium to it, and we're going to see if there's any evidence of a reaction. Now, magnesium is almost as chemically active as calcium, so if it does react, it should make magnesium hydroxide and hydrogen gas. And let's see if it does. Is it reacting? No, it's not reacting. That means something. That means that something's protecting the magnesium from the water, and that must be the magnesium hydroxide on the surface of it, which is real thin, because magnesium hydroxide is actually white, but you can't see it. It's not reacting, is it? So what I'm going to do is take 10 more milliliters of water, I believe, and I'm going to add magnesium hydroxide to it, and we're going to see if it will dissolve in the water. Almost. That's close enough, I think. And now what I'm going to do is take some magnesium hydroxide. This is what magnesium hydroxide looks like. It's white powder. And I'm going to add 1 gram of that to the water. Grams already measured out on a piece of paper. I'm going to pour it in there, add it, and then I'm going to shake it up. I'm going to see if it dissolves, but I don't think it's going to dissolve because we think that's what's keeping this from reacting. Does it look like it's dissolving at all? By the way, does that kind of look like milk to you? And do you know what the old name of magnesium hydroxide is? Magnesium. That's milk of magnesia. That's really it. Let's shake this up again. It's settled out a little bit. Let's shake it up. Get the suspension. Now this is acetic acid. This is 50% acetic acid. Acetic acid is the acid in vinegar. So this is the same acid that you find in vinegar. I'm going to add it, and we'll see what happens here. I'm going to shake it up. Does it look like it's reacting? Maybe. Let's shake it up again. Does it look like there's less magnesium hydroxide? I think there is, isn't there? Is there? Yeah, a little bit less. Let's check it up again. Keep doing it. Does it look like it's less? I think so. Yep, it is getting less. You can almost see through it now. Yep, it is, isn't it? Hello, everybody again. This is where we had the magnesium hydroxide. You see, it's almost all completely gone now. So it did react with the acetic acid. Okay. And then you have to use those calculations I showed you in the PowerPoint. You can actually show why it reacted with the acetic acid. That means if that coating on there is magnesium hydroxide, then the acetic acid should remove it, and then it should react with the magnesium. Let's see. Allow the water to come in contact with the magnesium. Is it reacting? It sure is, isn't it? Son of a gun. That's pretty good, isn't it? So I collect the hydrogen gas now. Should be hydrogen, right? Let's put this over here. I'm going to collect it. Look at that, baby, go. It's going fast. Son of a gun. You think there's enough to test it now? So what I'm going to do is I'm going to light this wooden splint again. Can you see the wooden splint? Can you see it all right? And I'm going to, I think there might be enough hydrogen in there so it'll only burn at the mouth of the bottle. Let's see. Yep, look at that. It's doing the same thing. Look at that. There it is. It's burning in the middle now, just like it did before, right? And you can see some condensation inside the bottle. Now, just for laughs, what I'm going to do is I'm going to see if I can light it. Nope. It's not lighting, is it? Nope. Just got to blow that out with a mask on. Now, this reacted. It's still reacting a little bit now. When we removed the coating with the acetic acid, it started reacting, but the question arises. We know that active metals react with acids too. So is it reacting with the water or with the acid? And how can we tell? Because there is an acid in there, probably might have been reacting with the water and the acid. Well, we don't know if the acid was the thing reacting. So what we're going to do is this. I'm going to add some sodium hydrogen carbonate, which is called sodium bicarbonate, and also called baking soda. It has the formula NaHCO3. This is both an acid and a base. The bicarbonate ion can pick up a hydrogen ion and act as a base, or the bicarbonate ion can lose a hydrogen ion and act as an acid. So it actually serves as a buffer solution when you put it in water, and the pH is equal to 8, which is alkaline, not acidic. So what I'm going to do is I'm going to put some baking soda into some water. Now what we're going to do is I'm going to take some baking soda, which is called sodium hydrogen carbonate or sodium bicarbonate. There it is. It's the same as we use in the kitchen, same stuff. And as I pointed out, it's both an acid and a base, and it buffers at a pH of 8. So I'm going to put this in here and dissolve it. Shake it up a little bit to get it dissolved. Then I'm going to add some magnesium, and at pH 8, the hydrogen ion concentration is 10 to the minus 7 molar, and that should be enough to allow it to dissolve. That's what I think anyway. You're going to do the calculations and check it out. I'm going to add the magnesium hydroxide, magnesium metal now. Just the magnesium metal. And see if there's any evidence of it is reacting, isn't it? Can you see it? Let me shake this up. And that's basic. That's alkaline now. So it's reacting with the water for sure. Can you see it? It is reacting. Can you see it all right? I think you can. It's not as fast because we don't have any acid in there now, but it is reacting, which means even in basic solution, it'll react if you remove the coating. It's reacting. It's slower, but it is reacting. There's no doubt about that. And that's pH of 8. Alkaline conditions. So it is reacting with the water, like we hoped it would.